Yo, good morning. Welcome to math class. Happy hump day. Yeah, we are going to start unit 3. Hopefully your test went well. By the time of this recording, I saw some of you did not submit it yet. So please get that in so that I don't give you a big fat 0. Let's see here. We are starting unit 3, which is all about functions. So we talked about the linear stuff. Now we're going to talk about what it means to be functions, different types of functions. Today is just a whole lot of vocab, to be honest with you. And then we'll just kind of talk through it as we go. All right, so first off, a relation. All right, you're going to see that word. A relation is just a set of points. Now you can see this set of points in lots of different ways, right? A relation, a set of points could be a table of values, x and y, just like, an x and y chart, something like this. It doesn't have to be consecutive or anything like that. Jump to 6, that'll make it spectacular, right? It could also be just, some set. So like the set of points 2, 3, -1, 19, 0, 5, -4, -4, and 6, 27. Right? That is also a relation. It's just a set of points. It could also be a graph. A graph is a set of points. I'm just throwing some points on here. It doesn't really matter where they're at. That is a relation, okay? Those are all things that you have seen before. I don't know if you've seen a mapping. So I want to show you one of those so you can tell if it's what's going on with a mapping. All right, so all of those are relations. Another form of relation kind of looks like this. And I'd have some numbers in here. Some numbers in here. And then they draw lines between them. All right. For mappings, this one on the left is always the x values. And this one on the right is always the y values, which we're going to talk more about here in a second. And those x and y values, basically they just connect to make points. So like this, go into that, is just the point -6, 4. 17, -2. 17 also goes to 3, so that would be another point. And then 20 goes to 0, like so. So a mapping is just another way to write a set of points. It is a relation, just like everything else that we looked at, just a different way to write some stuff. Okay? So, that's a relation. When we talk about sets of points, you can have domains and ranges, and those are fancy ways to say x values and y values. So domains, you see the word domain. We're looking for any x values. Any possible x values. When you list the domains of things, one thing that is important that always kind of comes up, you do not repeat the number. So for example, if I had the points 2, 6, 2, 15, 1, -5, and 2, -16, my domain over here is just going to be 1 and 2. All right, we don't have to write 2 3 times because it's just any possible x values. So 2 is a possible x value. I have that covered. 1 is a possible x value. Those are the only x values that we have in this set. So that would be our domain, 1 and 2. Now, the range is the y values. And same idea. Any possible y values. So those are words that are not going to go away. You want to have those in your brain. Going to high school, you're going to use them every single year. Talking about domains and range of different things. So make sure we know domain, it's always x's. Somehow figure that out. And then range, we're always talking about y values. And it's any potential y values that we might have. Okay? So, when we're looking at relations, those are x's and y's. We're talking about domains and ranges. Why would we be looking at these? Well, a lot of times we want to know if something's a function. All right? A function is something that you'll hear often. We often sometimes say linear function with everything that we talked about last unit. We had a lot of linear functions that we were solving for things about. Okay? And a function is when each input has exactly one output. I'll write that down. Each input has exactly one output. So that's the fancy way of saying that thing. Okay? If I look at a table of values, when I'm talking about inputs, inputs are always x's or the domain. Right? Those are all words that you're going to hear for x values. When I'm talking about a function, I specifically care about x values. I don't actually care about y values at all if I'm just talking about if something's a function. So if I had something like this, right? I'm looking at the x's, and if each input has exactly one output, what that means is that the x values do not repeat. All right? To me, that's the best definition. A function means that something has x values that are all unique. They do not ever repeat. So I'm looking at these x's. They're all different. So whatever this thing is a function because all the x's are different. All right? If we're talking about, that's functions. Now, functions could be what we call one-to-one. All right? If a function is considered one-to-one, that's kind of the opposite of what it means to be a function. Well, not really the opposite, because you can still be a function. So a function is one-to-one if no two numbers in the input go to the same number in the output. So no two domains, actually, we'll just say no domains share a range, or no inputs share an output. And so what that means now is that I'm looking at y values, because we're talking about ranges and outputs. So if something is one-to-one, that means that no y values repeat. Okay, so those are the fancy terms. I kind of made sure you got those, but really that's what you're looking for. If something's a function, the x's are all different. If something's 1 to 1, then those y values are all going to be different. All right, hopefully that's good. It's just kind of weird just teaching all of this vocab to you guys, and you're not here to know if that makes sense or not. So obviously we can have something that's not a function. Hopefully you guys got all this. Obviously you could just rewind the video if you don't. So for example, let's say I gave you a table of values. All right, and I might ask you something like, is this a function? So if I'm asking about it, is it a function? I'm looking at the inputs only. Are all of these inputs unique? Yes, they absolutely are, right? -6 is definitely different than +6. So this is a function. Awesome. And then I might say, hey, that function I gave you, is that 1 to 1? Is it a 1-to-1 function? And then you're going to look at these outputs, and you're going to say, well, I got a problem. 2 of the numbers in my input both go to 4 on the output. That makes it not 1 to 1. Okay? So that's basically the types of problems you're going to have in your homework. Is this thing a function? Is this thing 1 to 1? You're checking the x's, you're checking the y's. Is all that going to be true or not? All right, so that's kind of what you're looking for. Let's see. Talked about that. We talked about that. There's a lot of vocab. I wrote a little list on the side of my board here. If you didn't see that from before, I just want to make sure that. Let's talk about graphs. So if I have a graph. Right? Let's say I go like this. All right. If I want to check and see if this is a function and I have a graph, there's some cool stuff we can do instead of like looking at every single one of these points. If I want to see if something's a function, I can use what's called the vertical line test. The vertical line test says that if I use an imaginary vertical line, I'll use this marker, if it only touches the graph at one spot as it moves throughout the graph, then that is a function. So this one right here, you see there's nowhere that it would actually touch twice. This is a function because it passed the vertical line test. Now if I want to see if it's 1 to 1, I can use something called the horizontal line test. And the horizontal line test says the same thing. Is there anywhere where this horizontal line is going to touch more than once? Now, it might look like it's going to touch a bunch down here, but I promise you that's getting smaller because this is an exponential growth function. That's how they work. So this is a 1-to-1 function. Now, you might say, all right, give me one that's not then, Mr. Odie, so I can kind of see what's going on here, right? So let's say we had something like this, a parabola. Is it a function? Check the vertical line test. There's nowhere it would touch more than once, so yes, this is a function. Is it 1 to 1? Well, if I make a horizontal line, whoop, you see how it's going to cross in 2 different spots? That means it would the 2 x's would go to the same y value, not 1 to 1. because it touches in two different spots. All right, if I rotated this thing, this parabola, and I drew it like this, you can see now if I use the vertical line test, that it's going to touch in two, that's terrible. It's going to touch in two spots on the vertical line test. So this one would not be a function. However, if I check the horizontal line test, it actually would be 1-to-1 because there's nowhere it would touch twice on the horizontal line test. So those are some cool tricks that you can use when you're looking at graphs. The vertical line test for functions and the horizontal line test for seeing if something is 1-to-1. All right, we talked about domain, we talked about range, we talked about relations, functions. Oh, continuous and discrete data. We did not talk about that. So sometimes, I'm going to show you two graphs. This is pretty easy, I think. So if I have a relation, I guess I should say, on this graph, just a set of points, like this. And then I have over here, maybe I have some sort of cubic. Looks like that. All right, we call this data that's not connected necessarily, this is called discrete data. And discrete data is data that's just kind of like a scatter plot. It's not a lot, it's not connected data necessarily. Oftentimes it might be that it doesn't show a pattern or something, or it doesn't make sense to continue. Those are discrete data. It just means it's not connected. Think of it that way. Over here, continuous data or continuous function means that we are in there's some sort of connection between the points that are there. So this one, for example, has this line, that's squiggly line that goes through it. But those are made up of an infinite number of points, right? So this is a continuous set of data because there's a line connecting through it. Yeah. All right. That's a lot of vocab. I'm sure that's plenty of vocab for you guys because, that's a lot of new stuff. But your homework's basically just using the vocab. And then we'll kind of get into a little bit more meat on what functions are going to look like and what they're going to do. Cool. You guys have an excellent rest of your day, and I will see you later.